Hello and welcome back. It's time once again to try to fix a couple of things. And today on the workbench we're going to have a pair of PS4 Slims. Now I got these two, I bought these two together. I paid about $200 total for the pair of them. And these were both supposed to be no powers. And I'm hoping that this is not two dead south bridges, because that would suck. So let's go over what we've got going on right now. Let's just see. This one's plugged up. Actually, I have two cords here. I could plug them both in, I suppose. All right. Both plugged in. And this one, eject. Nope. Nothing. And this one. Nothing. How if I try to put a disc in? There's a disc in that one, I believe. And this one, no disc in that one, but she does not respond. So I feel like this is probably just two dead power supplies. I think this is a 2215, and this is like a 2115A or something. So this is a 500 gig. This is a 1 terabyte. Let's pop the hood on these things and see what we have inside. Not terrible. Not terrible. Little dirt. Little dirt never hurt anybody. How about this one? A little more dirt. A lot of fingerprints in there. Somebody's been inside of it, I would say. And looks like we have some left behind remnants of roaches. So these may be both dead power supplies due to roaches. So we will do a power supply repair-a-thon, I suppose. First of all, I need to see, let's see if we can confirm that it is the power supplies. So let me get these supplies out, and we'll see if we can swap them, and just confirm that's our only problem. Let's see, this one is not sealed, and this one, not really. The tape stuck back on there, but it's been opened, so neither of these are sealed. Let's see if we can figure out, make sure, just confirm it is the power supplies, and we'll move forward. Well, as I'm flipping these over, taking the bottom cover off to get to the retaining screw, you know, the bottom retaining screw for the power supply, you see more evidence of little insect infestation in both of them, it looks like. Just little hints here and there. So yeah, I think that gives us a clue to what we're in store for. All right, both supplies are out, and both appear to have the round pin connectors. You can see the model number of that one. That's a ADP 160ER, and this one over here is a N17 160P1A, but they both have the 4-pin round connector. So my spare supply here should work just fine. It has the round mating round pins. This one's ready to test. I've got my test supply in there. Let's just see what happens, shall we? Eject. Eject. Of course, there's a disc in there. It comes on. NBA 2017. Okay. And we're getting video. How about that? That was easy enough. Okay, so a good chance that one is just a dead supply. No other problems. It has good video out, so maybe not a. Let me wiggle this HDMI connector. We're not intermittent there. Okay, now I've got to shut this one down to swap the supply over, and that's going to take a few seconds. So I'll stop recording, and when I get a chance, I'll swap it over, and we'll start back up again with the other one. We'll try this one out over here. Okay, yeah, the one on the right here is definitely going to be the nastier of the two if you look down in there. Yeah, that's kind of nasty. So it's a little worse wear in the insect department. Well, let's see if I can get this spare supply in here with one hand. I don't know if I can. All right, move you out of the way. You come over this way. close as we can. So frustrating. So close. Ah! Took way too long. Alright, let's get this puppy in here. So, we are ready. Eject. Yes, there's no disc in this one. And we have power. And I think we're going to have video. We do. All right. So, we have 2 dead power supplies. So let's get those fixed and save ourselves our spare supply. Let me get these things inside and we will just fix them both and move on. We are inside at the workbench and we're ready to get started, I believe. Find my Phillips screwdriver. Let's get started with, let's just say this one. This is the one out of the left one out there. Probably the cleaner of the two. And it's time once again for me to recommend that you do not do what I'm doing, which is open up your power supply, because it is dangerous. And I am going to be extremely careful, and I may still get shocked. Because I did have these plugged in recently, and the capacitors in there some of them will still be charged. Every time. No live critters fell out, that's good. Although I do see where something went boom, splat. Okay, yeah. Right here, you can see it, and right there. So, he gave his life to take out this power supply. So brave. Okay, let's get started with this. Make sure everything is in the shot. I just used my this Agilent supply, Agilent multimeter, not supply. Continuity mode. I'll go ahead and zero it out to get rid of that residual lead resistance. Beautiful. All right. What is going on? We know we've got something went boom over here. He shorted out the high voltage. Let's just start simple. Where's our fuse? Fuse is good. This little resistor, which is a fusible resistor, it's good. Okay. What did he get then? Those are the only 2 actual fuses, you might say. This and the fusible 0.16 ohm resistor. Do we have a short right over here? First of all, let me check. I switched to voltage mode. I want to see what kind of resistance we got over this. What kind of voltage we have on these capacitors. 25 volts. So if they charged up, they discharged in a hurry. So let me short those out. It's just 25 volts, but it's going to mess with my meter readings, taking resistance readings and whatever if I don't discharge them. Yeah, nothing really across those. Makes me think that they never got charged, maybe. The only way they usually would not get charged if there was a something totally open, you know, between the AC and the rectifier, and because that's pretty basic on the front end of this thing. It's back in continuity mode. Nope, not wrong thing. Okay. Let's just start with the usual suspects, shall we? Which I may have switched the microscope to see some of this. It obviously got this right here. I mean, this is where he blew up. There's an optocoupler here. 314 ohms in both directions. I can't remember what's normal there. $50. Just looking at this MOSFET here. Is this the one? I'm trying to remember. Okay, so this is the standby power IC, which I can't read the number. Well, I'll take a quick look with the microscope. Sorry, I'm going to be blocking you for just a moment. DAP 46. Okay. DAP 46. Yep, a lot of the. Okay, DAP 46. Check these resistors right here. They are shorted, which they should be. They're very small values. Let's see. I'm assuming we did not have any standby voltage. We do have a DNP 12 over here. Yeah, this is getting too hard to see. Let me switch to the microscope view just to get a better view of what's going on. This stuff is small. So there's your standby power IC. This is what is responsible for generating the 4.8 volts standby. It doesn't look like it's blown up, but and if this is the MOSFET that it drives, and you can see where the critter blew up there. Took off some of the copper pad, but I don't think anything's open right there. This MOSFET does not appear to be shorted. And I don't think it is, because if it was, one of those fuses would have been blown. Either the 0.16 ohm resistor would have been blown, or the main fuse. I mean, something would have to give if that was shorted. And if this shorts, usually these two resistors will open up. Sometimes it'll pop this zener, but I'm measuring right at 1 ohm there. So the zener is not dead shorted. Yeah, 1 ohm. Which you think of, a 2 and a 2.2 in parallel, that's about right. And this is a 51. I'm sorry, it's a 510. Yeah, 510 ohm. That looks fine. I'm not seeing anything obviously burned, but it's pretty obvious where the burn happened. So he shorted from, this connection on this MOSFET, which is probably at an elevated voltage, 200, 400 volts or whatever. And did he short over to one or both of these opto isolators? And they won't take that kind of voltage at all. Let me go to resistance mode. want to check across this. 314 ohms. And 314 ohms. That one's up around a mega ohm. And see, this is the, if you look at one of these, you see that dot, that's pin 1. This is the LED side. This would be the anode, this would be the cathode. And on this side is the collector and emitter of the transistor inside here. And I can't remember off the top of my head which one is collector, which one's emitter. And you can see there are 3 oriented the same way, because they are control signals from this side over to this side. Your control signal comes in here and is converted over to here. Except this one goes the other way, because it's a signal going back the other way, back to this chip. So, is it as simple? Is it as simple as a bad opto isolator? What I need to do is I need to lift one leg of this, because it is basically an NPN transistor where the base is photosensitive inside this package. So if I lift one of these just to eliminate, the circuits that are in parallel with it, I should get basically infinite resistance. It should be an open, and if it's not, then that opto isolator is bad. Let's see if I can put a little magic flux on there. I just want to lift one side of it if I could. Doesn't particularly matter which one. I just want to isolate it from the rest of the circuit. Turn my fan on to get some of the fumes out of my way. I do need that to be cleared. Is that clear? Or is there a small sliver of solder back there holding on? Let's just see what the meter says. I'll put it in continuity mode. You can hear that. Are we connected from here to here? We are not. We're isolated. Now, what is my resistance? Go back to resistance mode. Between these two legs. 345 ohms. All right, that's a bad opto isolator. Yeah, that should be like, in the mega ohms if you could read anything. Because it's the collector emitter of an unbiased NPN transistor. I guess that makes sense. I mean, that's where he blew up, and he basically shorted this voltage to here. And what else did he do? I don't know. That's our first stop. Let's change that out. It just so happened that I recently picked up 100 of those EL1013s. Mauser stopped carrying them for some reason. I had got them from them before. So I had to resort to ordering them straight from China. And they're used in a lot of the supplies, so that's why I wasn't concerned about getting 100 of them. Okay. Of course, they were in the last package. Yeah, I have, well, you can't tell in that picture. I have a few of them. I guess they do fail sometimes. I mean, they don't normally fail. They fail when, with the assistance of bugs and lightning. And hopefully we don't have any damage on our DNP12 since it is optically isolated. Let's see. I don't like to use hot air on these boards. I have, but they are fiberglass and they will popcorn rather quickly. So I like to do it this way, even on the chips. And I know some people like to cut the legs off, and I've done that too, but sometimes I've gone to cut the legs off of some of these chips and it ends up, you know, levering up the pad. So, and the body is glued down. So what I like to do is break loose all the legs and then break the glue loose. Now, everybody remember which way this thing was turned. The dot goes up. Let go. All right. There's our bad one. Oops. And I have bumped my light source. There we are. And here's our brand new one. Come on. All right. We can get that tacked down. Maybe even use the little micro pencil. And I probably should clean up that little scorched mark where the roach met his demise whilst I'm cleaning in this area. Yeah, that right in there. Not really hurting anything, just doesn't look very good. Maybe a little scrubbing action. Yeah, he blew the outer layer off there, didn't he? I'm wondering what else he may have damaged. I think I'm ready to try this, but let's take a quick look around. What does this go to here? He went to this. So, it may have possibly damaged that one as well. This splits and goes in a couple of different directions. There's a zener right there. Let's just see. Zener's not shorted. Let's go to diode mode. That zener looks healthy. What about, yeah, Q41 here? This is the transistor that switches the power to some other ICs, and I have seen it get popped. All right, it is definitely not shorted. Is that the only thing we got? Is that one opto isolator? Okay. Well, let's find out, shall we? Get the microscope out of the way. get some power. Find my power cord. There's no power on this at the moment because I switch it off to the side. Let me check this camera. Okay. Need a convenient place to get the +5. There's ground right in there. Let's just see if we're getting our 5-volt standby now. And I'm going to apply power. We do not have 5-volt standby. And I didn't see it come up and go down. It's just not there at all. So we got something else going on. So do we get these capacitors charged up now? We did, 164 volts. So everything is working up until that point. You're getting your raw rectified DC there. It's not getting boosted by the power factor corrector because that's not running yet. That doesn't run until you get into enable the 12 volts. So I'm probably going to have to discharge that before I can move forward. Okay. I'm going to let that bleed off a little bit and I'll discharge it, and then we'll get back going again and see what else is wrong with this thing. Well, I've been doing a bit of digging, and I think I have found another problem. We're going to be looking right in this area. This is that DAP46. Let me start. I always forget to record on my microscope. Right in here, the DAP46. This is what is responsible for generating the 5-volt standby. So let's take a look at that under the microscope, and I'll show you what I'm talking about. All right, I am in continuity mode here, and let me make sure everything's in the shot here. All right, this is it. Pin 4 here is ground, right there. Pin 5 is the output to the MOSFET, drives the gate of the MOSFET. So if I check between ground and this pin 5, we have a dead short. Like a 1 ohm short. And if you follow this around, which I have, it comes around, goes through this little resistor diode network here, but it ends up coming down through here, right through here. There's a 10k ohm, I think it is, to ground. There, right around through here. And it slowly makes its way underneath the resistor all the way over to the gate of our MOSFET, the one that generates the 5-volt standby. Now this MOSFET does not seem to be shorted. I'm measuring like 150 ohms. I think that's because we've got a short on the other end. So I think the MOSFET is good. I think our DAP46 is no longer good because, which pin is it? I think it's pin 1 is the supply into this chip. If you follow that around the world, I lost it there. Here, underneath this diode, right here, under here, through a 200 ohm resistor, or sorry, 2k ohm resistor. Is that right? Yeah, 2k ohms. Right there. Is that the right one I meant to follow? I think I'm getting confused. I was trying to follow, yeah, let me follow it again. I'm confusing myself. I followed this before. Is that supply through a 2k ohm? Let's see, it's pin 1. Yeah, it's appears to be through a 2k ohm resistor. Must not use much power. So what you have, this right here is the, it's like a 13 to 15 volts or whatever it is. That's what supplies a lot of the ICs on this board. And it's switched right here. It should be sitting right here, and that's where it happened to arc across from. It sits here, it gets switched to here, and then comes down through this resistor, and then on and on and on. Anyway, ends up, if we check from, that point to pin 1 here. Yeah. So that's that supply coming in, and my theory is that it went through that other opto isolate. It could be bad. It went through it and popped this chip because the output pin is sitting at ground now. This pin 5, is shorted to ground. So at the very least, we need to replace that DAP46, and I am a little concerned about this EL1013. Okay, I'm going to replace the DAP46 and let's see what happens then. Okay, I have replaced that DAP46 with an LD5760, which is I've used in the past. It's a perfectly good replacement for it because I don't have any DAP46s. So let's see if we've done any good, shall we? Flip this over. Yeah, something like that. Let's get some AC into this. I'm trying to make sure everything stays in the picture. All right, do we have 5-volt standby this time? And let me get some AC power. There we go. 4.8. Excellent. Yeah, we're good. Let me make sure that comes up quickly. I don't think I was making a good contact over there. I'm gonna let that bleed off. We'll bring it back up again. It should come up immediately. Should not be any delay. And there's no load, and it's going to take forever to bleed down. Close enough. Down to like 0.5 volt. And bam. 4.8. I think we are good there. Now, do we have 12 volts? Let's see. I don't have a load on it right here, but I've got this, little 4-pin cable I've made up with a short across it there, across the appropriate pins. Just see if we can get 12 volts. We do, 11.92. Excellent. All right, I think this supply is good. Maybe we'll take it back out there and put it in the chassis, make sure this one works. I need to make a quick correction. I said pin 1 was the VCC in the supply voltage. It is not. It's actually an enable line. VCC is on pin 6. So I want to correct that. This is the data sheet for LD5760, and you can see the pin descriptions right there. But yeah, that's what was shorted to ground, was the enable line, which makes sense because that's where the enable comes from is it's sent across one of those opto isolators. That's how they enables the 5-volt standby, or shuts it down. More likely, it shuts it down sometimes when there's a problem. So yeah, I want to make that correction. It's pin 1 is actually a control pin, an enable or disable pin. We are back out in the garage, and it's time to see if we've done any good here. Let's see. This is the left one, the 20. I think this is the 2015 or 2115, a 500 gig model. Let's see if we've done any good. That's good. Fan spin, flashing lights, and the monitor just locked. All right, that looks good. So I think we are 1 for 2. It's time to move on to this one. And where's that supply? All right, it's inside. I forgot I left it inside. So let's get in there and see if we can make this 2 for 2. All right, back at the workbench. Our second power supply. I'm not sure how dirty this is going to be. That seemed like it had been opened before. It came apart real easy, and some roach bodies went flying. It's always great. I did a little bit of cleanup after that first one. I have to do some more cleanup. And I did wash out the plastic chassis of that other one, the cabinet, the case, because it was kind of nasty. All right, you gonna let go of it? There we go. All right, what do we have? Start with the basics. All right, do we have a blown fuse? We do not. Making sure I started recording, because sometimes I forget. And the resistor, our little fusible resistor, is open. And if that's open, we most likely have a shorted MOSFET. What about this one right here? No, not that one. But yeah, if that resistor is open, it's a 0.16 ohm resistor. If it's open, something has shorted somewhere. Let's see. Our standby supply is right over here. Let me make sure all this is, I need to zoom in a little, looks like, don't I? That's better. What's shorted? How about our standby MOSFET over here? Yep, that doesn't look good. So that is shorted. I should have those on hand. And I'm worried about, did it get the IC that drives it here? Sometimes it does. It depends on how it shorts. If it shorts back to the gate, you know, if it shorts 400 volts back to the gate, it's going to pop something in the chain, you know, something in line back to the IC and the IC itself. Let's look under the microscope just to see if we can see anything burned open. LD5760. What about the resistors that are in line with the, I think it's the source. Where are they? That'd be those 2.4 ohm resistors right there. Let me get them at 2R40. Sometimes those will short. I mean, sometimes those will burn open. Okay. I have a feeling we have a shorted Zener. Because what I'm reading, let me zero this out. Let me make sure let me go to resistance mode. and zero out, null out my leads. So because this is a low resistance we're trying to check here. Yeah, I'm measuring 0 across these two 2.4 ohm resistors in parallel. Well, I should get about 1.2. Now what these are, this is basically a current sample for the current flowing through this MOSFET with a leg still stuck across it right there. Look at that. So it's a current sample, and they limit the current sample with a Zener. I think it's a 9-volt Zener, 9.1. So somewhere, I can't remember, on this model, if it's on the other side of the board, you know, a through hole, or if it's a service mount. I can't remember on this particular model. That looks kind of nasty, whatever that is. A little corrosion of some kind. Where is that Zener? I don't see it. So maybe it's on the other side of the board. Let's flip the board over and take a look. Yeah, that's right. It's going to be, I think, let me get that in focus. Now, I can't remember if it's 801 or 802, whichever one is shorted right here. I'll switch to continuity mode so you can hear it. All right, it's not that one. It's gonna be this one right up here. Or I lied. That one. It's the very top one. Just like I said, right? ZD804. All right, because that is across those resistors. It's to limit how big that voltage is developed across those resistors. I guess to try to protect this IC. Just see if we can find focus again. So yeah, I don't know. Our 5760 may still be good. Let's just do a quick check there. Like we said, I think pin 4 is ground. Here's pin 1. Pin 5 is the output to the MOSFET. Does not seem to be shorted this time. So it may have survived. And unusually our resistors seem to have survived. Our R822 and 822A, they seem to have survived. So I'm pretty sure we got a shorted MOSFET and we've got a shorted Zener diode across these resistors. Yeah, you can see if you look. This is going to be right here, I do believe. Right through here. Right there is where it's going to the Zener on the other side of the board. Right there. And then if you come off of right here, it's going through this resistor here into whichever pin is the current sense, pin 3. So this should go to pin 3. Hey, I got it right. It goes under right over here, and then comes around to pin 3. So that's the current sample, the current sense, whatever you want to call it. So, okay. Is that all? Let's find out. Well, I dug through my part stash, and I think I've managed to gather up all the parts we need. A new MOSFET, 0.16 ohm resistor, and it's actually an 8.2 volt Zener. I think some of them use a 9.1, but this particular board uses an 8.2. So let's get that changed out. Well, I've changed out all the bad components I'm aware of. It's time to see if we've helped anything here. Let's find a ground right about there. I'll get on this 5-volt standby, and I'm going to flip the AC power on. 4.86. Excellent. All right, that looks good. Our standby is good. Is our 12 volts good? I'm going to put the probe on the 12 volt terminals. Where is my little jumper cable? Over here. And let's see if we can get some 12 volts. We do. Excellent. All right. Let's try this out in the chassis out there, shall we? Back out in the garage, we are ready to test our second PS4 Slim. The first one's been sitting there running, no hard drive in it for a while now, just kind of giving it a burn in. Let's move our HDMI cable over to the other one. And I should probably find the other power cord, which is laying here. Let's see if we have any. Do we have any joy this time? All right, I think we're ready. Blue light. Fan spinning. Monitor locking. PlayStation logo. All right, I think we're good. 2 dead PS4s. Dead because of the same reason, roaches. And they've been brought back to life. And I got a lot more cleanup to do on them. Like, I can't leave them in this state. I'll have to disassemble them and clean them out, get all the roach stuff out that I can, and new thermal paste, that kind of stuff. But I think I'm going to end the video right here. For those of you who like to power supply videos, I hope you like this one. If you did, please give me a thumbs up. And I will see you in the very next repair. Bye for now.